We have the ideas of sonar after 2 subchapters earlier. So here we are going to get a piece of information on some instruments that we may use in our marine environment. The single beam echo sounder still remain in present with greater precisions, even as the traditional equipment used on hydrographic survey operations. These echo sounders have also evolved from analog to digital recording. The use of digital echo sounder along with motion sensor and satellite positioning systems such as GPS optimize the productivity for survey works. The use of multiple single beam in one system installations, it is called as multi-transducer or multi-channel units, but this system is not widely used anymore. A ping of sound that generated by transmitter has certain narrow beam width, and it is in a conical shape. The deeper it gets, the wider the area of its footprint. This is generally the formula used to calculate single beam footprint. D equal to 2h. H is the depth detected times tan theta. Theta is the degree of the beam and divided by 2. Finally, this is roughly the raw data that we can get using the single beam echo sounder when we are following the run line and check line that we have planned for a survey. An advanced system to the single beam is the AGDS. In addition to depth, AGDS extracts two other indices that are E1 for roughness and E2 for hardness. AGDS works by integrating those components of the written echoes to provide simultaneous information on the nature of the seabed. Side-scan sonar. Side-scan sonar creates a picture on an image of the seafloor. It measures the strength of how loud the written echo is, or we call it as backscatter. Side-scan emits fan-shaped pulses down towards the seafloor and across wide angle perpendicular to the path of the sensor through water, which may be towed or mounted on the ship's hull. Hard area of the seafloor like rocks reflect more sound and have stronger and louder written signal than softer areas like sand. Objects or features that rise above the seafloor also cast shadow that can be used to guess the size of the features. The intensity of the acoustic reflections from seafloor of this fan-shaped beam is recorded in a series of cross-track slices. When stitched together along the direction of motion, it creates an image. For example, here, we can see the limit set is about 120 feet and the depth recorded is about 24 feet. Something was detected over here with the shadow behind it, and another detections were in the water column area too. A multibeam sonar is an instrument that can map more than one location on the ocean floor with a single ping and with higher resolutions. Unlike other sonar, multibeam systems use beamforming to produce a swath of depth reading. Swath is a strip of points in the direction perpendicular to the path of the survey vessel. It is kind of same like cross-track in side-scan sonar. Instead of one, the beam produced varies. Some are with 128 or 256 beam and others are lower or even more beams than that. Using simple geometry, the cross-track distance, y, below the transducer can be calculated by y equal to r, the distance of the slant range, times sin theta, the degree of the beam from its center. For backscatter data, multibeam provides one value per beam while side-scan sonar provides a continuous value along with the image. Another difference is the side-scan sonar, there is no direct information like height or size about the detections. We will only base on our rough estimations, and some of the studies also found that multibeam sonar are more accurate than the side-scan sonar, as this example of multibeam data. Another thing that is common in marine and fisheries field is the fish finder. It also uses the concept of sonar that we know. The use of it contributes a big help to the fisheries community either in massive catch or individual and sport fishing. Normal setting is with the fish symbol enabled and the view would be like this. We can see the fish-like features is floating on the screen. With the fish symbol feature disabled, the device can learn to distinguish between fish, vegetation, debris, and etc. However, when it is disabled, the fish detected will usually appear on the screen as an arch. This is because the distance between the fish and the transducer changes as the boat passes over the fish or the fish swims under the boat. The distance at the edge of the detection, or sometimes called as the lobe, is actually longer than in the middle, which is the nadir point. When the fish enters the leading edge of the sonar beam, a display pixel is turned on. As it moves toward the center of the beam, the distance to the fish decreases. This is because when the fish swim directly under the transducer, it is closer to the boat and the stronger signal will also show a thicker line. The same happens as it then moves away from the transducer. That's it for now for the example of Sonar Instruments. That was a brief information about single beam, multi-beam, LGDS, side scan, and the fish finder. Hope that you can explore more about sonar.